Okay, so let's look at 82 on 311. H of x equals 1 divided by 4x plus 5. Same question. We're asked to identify two functions, one which will be the inner. By inner, I mean the first function we apply. And one will be the outer. Since we are given this, what is the name of the inner? Because that's also important. Because I can mess up f and g or mix them up. Yes, the inner is indeed g of x. Which function will you consider the inner? Right. I have to perform this first. If I don't calculate this first, I can't proceed. What will be the second function once I have one single number here, just one number? What will that be? That's it. So the outer function, what is the name? Yes. Is this better? Not really? Okay, so let's look at this function. Let me copy it because I deleted it. 1 over 4x plus 5. If I ask you evaluate for x equals 0, where will you start? Will you start with 1? Will you start with 5? Where will you start? 4x. Correct. So then you can consider that you are calculating this first. And you get 5. Which function will you apply to 5? Over 1. Exactly. Not over 1. 1 over 5, which is 1 over x. So that's how we come up with this as being the inner function that I have to perform first. And when I'm done and I get one number, I apply this function to 5 by getting 1 over 5.
What is a decomposition of a function?
Breaking it up.
Okay.
Okay, sorry about that. I should have mentioned. So function composition is from two functions we get a complicated one. Decomposition, we're going backwards. Okay. Sorry about that. Good. Other questions here? Other questions? Okay, I just want one more thing before we move on. On page 311, I would like to look at, let's say problem 92. In 92, we are asked to find f cum g of 1. We do not have the functions. I will show you the graph in a moment. But first, I want to identify what this is asking me to find.
G of x. Oh, 1.
Very good. Good. Where do I start? Where is my starting point? Just name it. Correct. So I'm looking now at the graphs. So here are the graphs. This in blue is f. This in purple is g. So I'm asked to find g of 1. Can anyone find g of 1? Yes. G of 1 is -5. Okay, so then I write, thank you, Eddie. So this is f of -5. Now I'm going to the blue graph to find f of -5. Oops. Okay, let's look at the blue graph and find f of -5. F of -5 is 3. Do you all agree? Yes? Very good. So that's the answer then. 3. Any questions? Any questions? Any questions? Okay. 2.7. I'm not going to put the title right now because I want you to tell me what the title should be. Okay? When we started functions, we looked at 3 scenarios. So these were the 3 scenarios that we looked at. I'm not going to put numbers. You know what I mean. say about the first possibility or the first case? What did we say about this? Yes, indeed. This is a function. And now I'm going to ask you this. What if I want to create a function that has domain this and range this? Can I create a function?
Well, yes, it would just be y equals x, right?
Nope. So question is, can I create a function going backwards? Does this correspond to only one y value? Does this correspond to only one y value? Does this correspond to only one y value?
Inverse functions.
We have to come up with a gag order here. Okay, so because this function is one-to-one, not because it's a function, because it's one-to-one, meaning to each y, also only one x, to each y, only one x, and to each y, only one x. This function has this property, 1 to 1. That's why I can create an inverse function. Coming back here. Number 2. What did we say about number 2? Very good. Not a function. We call it relation. We're not interested in it here. What about this function? Oh, is this a function?
Yes, but it's not one-to-one.
Exactly. It is a function because each x corresponds to only one y. Each x corresponds to one y. Each x corresponds to one y. But indeed, so this is f of x, but not one-to-one, which means if I want to go backwards, can I create an inverse function?
No.
No, because this x for the inverse will have two y values corresponding in the other set. So this is not one-to-one. Is it a possibility in real life? Yes. Can I create the inverse? Yes. It will be a relation, however, not a function. So our first note here is, and I need your help, only functions have functions. I'm missing 2 words. More than 2 words, actually.
One-to-one.
Only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. I'm going to look at a few graphs, and you'll tell me which ones are one-to-one. And Tom is on the gag order till the end of the class tonight. That does it. Mess me up. Okay, just kidding, of course. Okay, so I have this graph. And I have this graph. And are these functions, first of all?
Yes.
By the...
Vertical line test.
Good. So now I'm asking you, let's start with this one. What type of function is this?
So it's a line.
Yes, it's a linear function. Very good. Is this one-to-one? By the horizontal line test this time, any y value will correspond to only one x value. Any y value will correspond to only one x value. Not just that it's a function, but also one-to-one. Now, what type of function is this? We haven't talked about exponential yet. They're coming up in chapter 4. So this is quadratic. Is it one-to-one?
Nope.
No. By the horizontal line test for this y value, how many different x values do I read? 2. Not one-to-one. Which means this one will have an inverse function, but this one will not have an inverse function.
We'll have an inverse relations.
Correct. Correct. Very good. So let's take a look at a few examples. I'm on page, which page am I on? I'm on page 321. Page 321. Okay, I want to look at these graphs. Is this the graph of a one-to-one function?
Yep.
By the horizontal line test, it is. Is this the graph of a one-to-one function? No, because for a y value, is this the line of a one-to-one function? Careful, it's a little bit deceiving. This is absolutely horizontal.
So it's not one-to-one.
It's not one-to-one. Very good. Perfect. How do I find? Give me a linear function, please, because we already know it's one-to-one.
Y equals 2x plus 3.
Very good. So this is a linear function. Is it one-to-one?
Yeah.
All linear functions are one-to-one. So there is a 4-step procedure for finding its inverse function. First of all, let's start with the notation for the inverse function. I'm going back to the bubbles. This is the function f of x going from set A to set B, domain range, of course. And this will be what? A function going from B to A.
Inverse.
It's inverse.
F inverse of x.
As I said, he can teach this class.
I
Indeed.
remember the stuff from a year ago.
Okay. This is how we read it. F inverse. This is not 1 over f. I know you see there f to -1. Oh, is that 1 over f? No. It's not 1 over f. The notation, or the way we read it, is f inverse. And this is the notation for the inverse function. F inverse. Okay. So now I'm coming back to the 4-step procedure. Step number 1. Replace f of x by y. First of all, can I do that? Am I allowed to? Will you accept?
It has to be y inverse too, though, right?
Not yet. Will you allow me to replace this notation by y?
Mm-hmm.
Are they the same?
Yeah.
Are they measured in the same way? Are they graphed the same on the same? Okay. So I'm going to say y equals to x plus 3. In step 2, interchange or swap, whatever you want to write, x and y. Now I'm going to ask you, am I allowed to do this? And before you say anything, let's look at the bubbles. This is x for f of x. What is this value here for f of x?
Y.
Perfect. But now, what is this value, this number, what is this number for f inverse?
Y inverse. 1 over y.
Okay, let's start from the beginning. Indeed, this will be the x value for f inverse that will return the y value, right? So if I have, through the function, 2 belongs to 3, through the inverse function, 3 belongs to 2. Because that's the definition of the inverse function, brings everything back where it came from. So I am allowed to interchange x and y. So I'm going to do it right here. X equals to y plus 3. X equals to y plus 3. In step 3, solve for y, of course, because y is the f inverse I'm looking for. So, how do I solve this equation for y? What do I have to do? First step, quickly before he says anything. Say it again.
X and Y.
Yes. First step.
-3
Very good.
divided by 2.
Very good. So I get y equals x minus 3 over 2. We managed to beat him once today.
For now.
For now, exactly. We really have to be sharp. Okay, in step number 4, replace y, this, by what I'm looking for. What am I looking for?
F inverse of X.
That's it. This is F inverse. Before we do anything else, I would like to graph these two on the same coordinate system. So I'm going to go back to, I'm going to write them one more time together. So we had f of x equals 2x plus 3, and we had f inverse as x minus 3 over 2. Okay. This is linear, so I want the x and y intercepts. When x is 0, how much is y?
3.
Very good. Can anyone give us the ordered pair that we just determined for the function f?
0, 3.
Now I have to make y equals 0. I move 3 to the other side. Negative 3 equals 2x. So therefore x equals negative 3/2, or negative 1.5. Only because I need to plot. What is the ordered pair now? Very good. Ready to graph? I am going to graph the function in blue. So I have 0, 3 and negative 1.50. And here's the graph. And this is the function f of x, 2x minus 3. No, 2x plus 3. I refuse to find points for the inverse function. I want you to come up with 2 points with no calculations.
0, negative 3. Right?
No. Okay.
0,
So-
negative 1/2.
Correct. All we have to do is swap. Remember, if the function takes 2 to 3, f inverse has to bring 3 back to 2. So if the function has 0, 3, the inverse function must have the ordered pair.
Flipped.
So 0 corresponds to 3, and for the inverse function,
3, 0.
exactly, 3, 0. In orange. Can anyone give us another ordered pair that we need to plot?
0, negative 1.5.
Since all points are flipped, as Tom said, now can anyone give us the equation of this line?
Y equals X.
We have to put him in a straight jacket. That's it. There's no other
Way to
way.
gag me.
Yes. So
Okay.
So what do we notice here? Here's what we notice. Yes, that's a perfect answer. So, in other words, the graphs of f and the graph, or the graph of f and the graph of f inverse are, and I'm missing a word, and you'll give me the word, not Tom. So the graphs of f and F inverse are with respect to the line y equals x. Which word am I missing there?
Symmetry.
Thank you. The graphs of f and f inverse will always be symmetric with respect to line y equals x. Why? Look here. This distance must equal this distance. They're exactly flipped over that. This distance must equal this distance. That's why this point where they intersect, this must be, I'm just making it up, -5, -5. And when you flip it, it's still -5, -5. So that's why it belongs to both, because it's on this line, which means x value and y value are identical. And if you flip them, you still have to get the same point. So this point belongs to both, because both x and y at that point are the same. Any questions for me? One last concept, and then we'll look at another problem. Again, I'm going to leave the title alone, and he's not going to tell us this time, because I make sure he can't. Okay, so let's say you have X dollars in your pocket. Okay? And I come in and I say, here, I want to give you $5. And then a minute later, I say, give it back to me. What happened to the amount of dollars you have in your pocket?
Increased by 5, then decreased by 5.
And at the end of the day, what happened? Nothing. The answer is nothing, right?
Net change.
So here's a question for you. Addition by 5 and subtraction by 5, are they inverse operations?
Yes.
Because nothing at the end of the day, I can apply them in any order.
If you do one then the other, it means it doesn't make a difference.
They annul their effect on x. I can say, please give me 5, and then a minute later I say, take it back. So it doesn't matter, the order is not important. I can take 5 and give back 5, or I can give 5 and then take it back. So f of x, we created this function of x plus 5. And what is g of x, the other function that we created? X minus 5. One more time. This is what we did. If we create the function composition this way, when I subtract 5 and then give it back, or the other way, when I give you 5 and then I take it back. So in any order, what should the answer be if these two, if they are of each other? So if they are, thank you. If they are inverses of each other, which we already proved, the function composition in any direction must equal what? X cubed? No. X plus 9? No.
0. X.
Exactly x and nothing else. Nothing happened to x. This is called the property of inverse functions. Only if this happens in both directions, and I just get plain x, not x squared, not 3x, not x over 2, nothing, just plain x, then these two must be inverses of each other. Yes, please.
Would you mind showing the algebraically?
Of course. So let's determine f come g. I was going to pick other problems, but why not work on this one now first? Very good point. So f come g, by definition, what does it equal to? F of g of x. Again, you don't have to do this. I'm just trying to make a point so you don't forget. What do I put in here? Very good. Now I look at f. What does f say? F says blah plus 5. So what do I write? I have to write the blah first, which is
X.
so blah is x minus 5 and then plus 5. And the answer is?
X.
Let's look at the other one. G comp f of x. By definition, what does this mean?
G of f of x.
Very good. Again, you don't have to do that. I'm just making a point. I have g of
X plus 5. Giving you x plus 5 minus 5 equals x.
what does g say? G says g of blah equals blah minus 5. But now blah is this. So I have x plus 5 minus 5, which happens to be x. Therefore, both ways, they must be inverses of each other. There is no other way. If there wouldn't be inverses of each other, I would get x cubed, or maybe x plus 1, or maybe the square root of x, or who knows. But if I get x in both directions, they must be inverses of each other. Any questions? Very good. Let's look at, let's say, number 6 on page 321. Same question. We are given f of x, which is 3x minus 7, and we are given g of x, which is x plus 3 over 7. And the question is the same. We are asked to see whether they are inverses of each other. And we are specifically told, do not find the inverse. Because I could find the inverse of this with a 4-step procedure and see if it's that. No. We are asked to use the property of inverse functions to show whether they are or not inverses of each other. How do I proceed? What do I have to determine? What do I have to calculate? Other than Tom. He's asleep already now, and anyway.
It is almost. That's about halfway to 5:30.
Quickly before he wakes up. What do we have to determine? In order to find whether they are or not inverses of each other. Of course. I have to calculate f comma g. And then I have to, if this is x, then I have to calculate g comma f. What if I get here x plus 5? Do I have to calculate g comma f? We don't care about g comma f anymore.
Yeah, because it's not.
They are not inverses of each other.
Yep.
Correct. By definition, what does this mean?
F of g of x.
Indeed. Which is f of
X plus 3 over 7.
which is 3 multiplied by x plus 3 over 7 minus 7. Good. This is 3 over 1, so I have to multiply.
3x plus 9.
Very good.
7.
Minus 7. I have to find the least common denominator, which is
7.
good. Then the top of the second fraction gets multiplied by
1.
as I said quickly before he wakes up.
You multiply 7 by to get 1.
Okay, you have to multiply by 7. So 3x plus 9 minus 49. That's good. We wore him out. That was the idea. Good. So, question, does this equal x?
No.
What do we conclude about the given f and g then?
They're not inverse.
And we don't have to determine the other one. Therefore, f and g are not inverses of each other. They are not. Okay, so let's look at another problem in which we are asked to find the inverse function. Would you like to make one up, or I will?
You can.
Oh, thank you for the vote of confidence. I appreciate that. Okay, so let's say, because one of my students asked me about this, and I believe it's in my math lab. So let's look at 28 on page 321. 28, yes, 28, sorry, on 321. So here it is, f of x equals 2x minus 3 over x plus 1. Of course, x cannot equal -1, it's very clear. We are told that this function is 1-to-1, and we are asked to find f inverse. F is 1-to-1, find f inverse. It's the 4-step procedure that we have to go through. First step, please. What is the first step? We replace
Replace y with f of x with 1.
number 2. Step number 2.
Switch position.
Very good. X equals 2y. Oops, I'm going to erase that. I'm not sure why I wrote plus. Over x plus. Good. In step 3, what are we trying to do in step 3?
Solve for x.
Careful.
Y.
We are looking for f inverse. Right. Here's my hint. How do I solve this? Very good. So x distributed to y and 1. And this side, 2y minus 3. I'm after y. How do I proceed? Look at the equation and say, yes, but now you have to do this.
Add 3 to both sides.
Say it again.
Add 3 to both sides.
I'm not concerned about 3.
Oh.
I'm trying to solve for y.
Divide y.
I can never do that.
Subtract y.
Subtract. What am I subtracting?
Get rid of the y from one, move it to the other.
Okay,
Essentially.
just dictate.
2x equals 3y minus 3. This feels wrong.
Can anyone dictate the next step? Yes, please, Eddie.
Get everything with y on one side.
Of course.
And then factor out.
Very good. So xy minus 2y equals negative x minus 3, and then factor out y. Awesome. So when I factor out y on the
X
left,
minus 2.
indeed, and then negative x minus 3. Now I'm in the position of dividing. What am I dividing by? X minus 2, correct? Good. So negative x minus 3 over x minus 2. Of course, I have to write that x does not equal 2. And in step 4, I do what? Replace.
Replace y with f inverse of x.
Indeed. This is it. That's how we find the inverse function. Any questions? Any questions? We have 6 more minutes. I would like to prepare something for next time, in which we will finish chapter 8. So don't forget a few things. my math lab, I will redo all problems we did in class immediately. And I will do everything from 2.6 and 2.7 as soon as possible between now and Thursday, and come back if you don't get certain problems, come back in with a list and say, show me this, show me that. The other thing that I was going to mention is, some of you came in late. If you take test 1 in my math lab, which I will release, you have 120 minutes. You can take it between now and next Tuesday, an unlimited number of times. If you get 100% on the test, then I will add 5 points to your current grade. I may add more, but I want to see it first. Okay? So one thing, as I said, we have 5 more minutes. I'd like to talk about, here is a point, here's another point, here's point A, and here's point B. This is something from the previous course. So this is section 2.8. And I would like to determine the distance between these 2 points, the length of the line segment. Because this is point A, I'm going to say it has coordinates x1, y1. This is x1. And what is this? y1, very good. And I'm going to say the same thing, that B has coordinates x2, y2. And I'm going to form a right triangle, this right triangle. And I would like to be able to determine this length. And I'm hoping that I can determine this length. And then I will use what theorem in a right triangle? Anyone other than Tom? The Pythagorean theorem, thank you. As I said, we really have to be fast. Okay, can anyone give us this length from what you see here? Don't invent anything, from what you see here.
X2 minus x1.
I agree with that, x2 minus x1. This length minus this piece is x2 minus x1. What about this length?
y2 minus y1.
y2 minus y1. And now, in the Pythagorean theorem, the hypotenuse squared equals the sum of the squares of the 2 legs. So what do I have here?
A. X2 minus x1.
What do I have here?
y2 minus y1.
Now, what does this represent after we take the square root from both sides? Take the square from this side. I should write plus or minus. Why I cannot write plus or minus in this particular case?
I guess because it's a shape.
It's a distance.
Right.
Correct. So I have the square root x2 minus x1 squared plus y2 minus y1 squared. Can I, this is the distance formula. Can I further simplify the distance formula?
I mean, I've seen it as a squared plus b squared equals c squared.
Right, that's the Pythagorean theorem, correct. But my question is, can I further simplify this, or this is it?
That's it.
Of course, I cannot simplify because the square root of a sum is not the sum of square roots. So this is it. That's a distance formula. I see you're very anxious to pack and leave anyway.